Hey everyone, welcome to the Refiner Testnet. My name is Niall and I'm joined today by my colleague Pranay, who is a senior software engineer. And today we're going to be giving you an overview of how to get up and running as a refiner on the testnet. Now before we get into the actual onboarding, let's go over some general housekeeping. So you need to have your refiner up and running by July 7th at the latest. While the testnet begins officially on July 5th, we're giving you guys enough time to actually get up and running, and that's why we're leaving it until July 7th. As at this time, we'll begin evaluating performances, and then when it hits July 19th, you can stop running the refiner, and at this period, we will actually be evaluating performances. Now, for any support or any feedback you want to give, please do just get in touch with us directly in the Discord channel, and specifically use the testnet support channel. We'll answer any of your questions there, and on top of that, we will be hosting office hours on July 5th and 6th to help with any onboarding questions that you may have. And this will give you an opportunity to get in direct touch with one of the engineers in the team who can help you with any queries that you may have. Now, before watching this video fully, I'd highly recommend checking out the Refiner white paper and the GitHub repository as well. This way, you're fully up to speed with the refiner and it will surely help with the actual onboarding. So let's get into some of the prerequisites of the onboarding. First and foremost, if you need to make any changes to the addresses you provide, please do get in touch with the Covalent team as soon as possible. These two are pivotal to the onboarding, and if you need to make changes to these, it has to happen prior to July 7th. So there's two things you should have provided: the operator address and the reward address. Okay, then you need the actual testnet tokens. So you should have received the testnet CQT directly into your reward wallet, and you need the dev tokens from Moonbase Alpha, and these are essentially the gas tokens. Please use the faucet for this and fill your operator address and your reward address with both of these. That's everything. Okay, you're officially ready for the actual testnet onboarding. I'm going to hand you over to Pranay, who is going to bring you through that.
Hi, thanks Niall. I'm Pranay Wilson. I lead the engineering efforts of the Covalent network. And it's a great pleasure, and we are really excited to release the next phase of the Covalent network, the Refiner. The Refiner brings unparalleled insight into blockchain data through concurrent re-execution technology. And given this opportunity, I want to talk a bit about the architecture behind the Refiner, go into details about the documentation that's available online, an onboarding screen share about how to set this up for validators, and finally end it with taking it back to Niall. So let's start with the screen share. The data processing framework. The primary purpose of the refiner is to transform data from block specimens. And block specimens, as we all know, are canonical representations of blockchain data that have been created in the first phase of the Covalent network. We currently have validators exporting block specimens into IPFS and also making transactions on the Proofchain smart contract, quoting the work that they have done. Once we have this list of transactions that have all the CIDs, which are the content hashes of the block specimens, we can pull them in. So the purpose of the refiner is basically to read a block specimen and create a pipeline. What does that pipeline look like? The pipeline primarily consists of the Proofchain smart contract listener, a block specimen extractor, a block specimen decoder, and a block specimen transformer. And for each block specimen, we create a separate block specimen transformation pipeline. At the end of the pipeline, we upload these transactions to a proof chain. So let's see it from the beginning. So BSPGeth here creates a block specimen. It exports it in a queue through readers to the agent. The agent further processes this, compacts it, and then pushes it through IPFS Spinner. BSP agent and IPFS Spinner are parts of our open source tooling that we have released previously. Once the block specimen has been produced, we make sure to store it locally and also make a transaction to the proof chain. This transaction contains the CID of the IPFS file, which is the block specimen. And so the work of the refiner starts with pulling in this data from the proof chain, which in the future is going to be the Covalent L1. Further, it queries the IPFS spinner, which has a knowledge of all the IPFS CIDs. And so once we query the IPFS spinner, we get the block specimen binary file, and we then put it in the pipeline to start converting it. Once we start the conversion and the processing, we make sure that we have the block result binary file, which we then make a proof transaction for on the proof chain or the Covalent L1. So that's the overall architecture of the refiner. And further, we're going to look at how the docs have been set up, which is the onboarding for all the validators, and go further into the GitHub repo and the various tooling that we provide that comes built in with the refiner. As an example, I have a machine here that is ready to run rudder, and we are going to go through the documentation available online to see how to set this up. So basically we need 3 services running for the refiner, which is rudder, IPFS spinner, and EVM server. These are less IO intense as the previous phase, BSP get and BSP agent, and they don't require as much bandwidth as a result, because the only thing that you need is access to the EVM public blockchain partner, which is Moonbeam, and of course the clients to send the transactions. IPFS accesses the network to be able to upload and download block specimen files as well as block result files. So we'll talk about that in a bit. So the minimum requirements are extremely low, as we said before, and you can get away with a 2-core machine with 3 gigabytes of RAM and very low hard disk drive space. But make sure that your download internet service is pretty stable. So once you've filled out the form to become an operator, make sure that you have the testnet CQT and that you have staked the testnet CQT on the staging link, and make sure that you have the dev tokens available to be able to send the transactions. Once you've met the minimum CQT staking requirements, set up the Aragon node and Node Ethereum mainnet environment variables, and you can get this through discussions on Discord. And please ping us there. Create a Web3 storage account and get a valid API token to update the Web3 JWT. And finally, turn on the operator status on the dashboard. So once you have done this, we are ready to run rudder with Docker Compose. So all you need to do is first clone the repository. So let's go ahead and clone that here. Once it's done, we can go ahead and look at files, what's in there. The file that we care about is the Docker Compose Moonbase file. So let's go ahead and see what's in there. Docker Compose Moonbase. You can see here that it's divided into 3 services: the IPFS spinner service, the EVM server service, and the rudder service. Rudder here acts as an orchestrator of the pipeline that enables the functions of the EVM server and IPFS spinner to run concurrently over block specimens to transform them into block results. We primarily need these 4 environment variables, and some of these are given on the left here, which are pretty apparent. You can find IPFS spinner at 3001 and EVM server at 3002. These are local services, and the other things are some things that you can grab over the network, which is the Node Ethereum mainnet and the Aragon node. And in this case, the Node Ethereum mainnet is our Moonbase node because that's our EVM public blockchain partner. Make sure you have the correct BRP private key for the operator, and make sure that you don't have the 0x prefix here. And then this is running in the dev environment, basically for Moonbase Alpha. Once you run this, you'll be able to start the block specimen event listener, which starts the pipeline. And that's all you need. So I've already set this up for the case of Moonbase with a systemd file, and you can find the systemd sample service unit here. Of course, I'm not going to show you the file because it exposes sensitive environment variables. But with this, you're able to start and stop the application remotely, and also be able to control the restarts and crashes, etc. So a lot of easy handling comes from using this. So let's go ahead and see what it looks like. When I start, just make sure that Docker is running. Docker PS. So it seems to be running, nothing's in there. Let's make sure that we have the images in there. If we do, let's do it from scratch and remove all the images that are there before. So we download the most stable ones. Remove force, so you can remove that. Let's go ahead and remove the other 3 as well. that. And finally, the last one. Let's check one more time. We have no images here, so now we can start the pipeline. System control, start rudder test.service. And on the right, I have the logs available. And here what we go ahead and do is you can see that the containers are already existing or they are pulled from the repository, and we can start the pipeline. And the pipeline basically involves going through the installation of rudder, in which case you can see that the application is being built. And this happens really quickly, and we can see that the pipeline starts. Once the pipeline starts, you can see that the block results are written temporarily, and then finally CID is generated, which is then uploaded. And for this, you have usually the CIDs are available on IPFS, so we make sure that they're going through the IPFS spinner system. Yeah, and that's it. So you can see the counter for BRP metrics. They are available here. Further, if you go into the rudder repository, you can also set up the Grafana dashboards. If you go here in the documentation section, you will find that we list out all the different mechanisms of how to set up a Grafana dashboard, where you can capture these block results as well as pipeline successes and be able to dwell further into how well the refiner is doing. Once it has all the information in there, you can display this in this particular dashboard, and you will see that the IPFS metrics as well as the pipeline success metrics are constantly increasing. So let this run for a while. It gets the file, it starts the BRP, it starts the transaction. The EVM server captures it. There's an execution here, and it finally uploads it. And here you have the total execution time. So that's the total execution time for the entire pipeline for one given block specimen into a block result. And we can go and fetch this file at this CID. And the pipeline continues as more and more block specimens pour in, and you can statelessly manage them with Docker Compose. So that's the onboarding with Docker Compose. Further, we can also talk about running this from source, which is a little more involved. So let's go right into it and let this run in the meantime. I'll go through the instructions, which are basically you need all these particular tools available on your machine to be able to do it, irrespective of which machine it is. And we can focus on the Linux environment, where you have to run these three applications separately and set them up. So in order to install all the dependencies, call this particular call, and this will install all the build tools as well as the different tooling required by the different repositories. We also need the three languages, so we use ASDF in this case, and we make sure that to install Erlang, Elixir, and Golang. Rudder runs on Elixir, which has Erlang underneath, and this allows us with the concurrency and the fault tolerance that we require to run such a highly concurrent performant transformation engine. Once we have set all the different environment versions for the particular languages, we can go ahead and set up the environment variable management tool, which is dir-env in our case. In case of Linux, also make sure that you get the IPFS, go IPFS repo and install it using IPFS, bash install sh, and initialize it using IPFS init. If you have any permissions issues, please execute this command, and this should fix anything that's got to do with permissions required to access the network, as well as to make it function in a particular configuration. Further, to run EVM server, you basically make sure that you clone the Aragon repo, make EVM, and then run it in server mode. And this starts the EVM server in port 3002, as we spoke before. An IPFS spinner can be cloned from this particular repository. You make the binary with server DBG, make sure that you pass in the web3JWT, and you make run. And this starts a listening on port 3001. If you have any issues with migrations, we have instructions in there. and finally run rudder, which is very similar to what we did before. So you clone the repository, you check out main, you make sure you have the nvar-c local, pass in all the correct values for the environment variables, and you make sure that you upload them into your bash, and you call this to download all the binaries as well as install all the tools, and finally run the application. Once it starts up, you can start the event listener, and this will start a rudder from source. So that completes the onboarding for Refiner in both the Docker Compose way and the build from source way. And now I can hand it back to Niall. Thank you.
Thanks, Pranay, for walking us through the Refiner onboarding. Okay, if you have any questions or concerns, please do just get in touch with us directly in the Discord channel. And remember, we are hosting office hours on July 5th and 6th. So please bookmark those dates if you want. Thanks.